All right, it is January 6th, 2022, and it is the second day that I am locked out of my CPS Gmail account. So, I figured, you know what? May as well make another tutorial video. And this time it's going to be over something that we're going to be going over very soon called empirical formulas, also molecular formulas. Now, this video is going to be in the context that I've already taught it and you understand it completely. So, just a quick recap in case you have no idea how to do an empirical formula problem. Don't forget the empirical formula song. Percent to mass and mass to mole. Divide by the smallest and return to whole. If you can remember that jingle, then you are set. You can do these problems, these 4 steps. You don't need to memorize them because you know what? You know the song, or the jingle, or the march, or whatever you want to call it. So, how do we do something like this? A compound contains 63.5% of silver, 8.20% of nitrogen, and 28.3% of oxygen. What's its empirical formula? Okay. Well, we know this, okay? We need to start with our givens, which are our percents. Remember, we're just converting percents to mass in the first step. So let's just deal with silver first. 63.5% silver. And we're going to convert that to mass. So I'm literally just going to write an arrow, and I'm going to change that into grams of silver. So remember, it goes percent to mass, and then mass to mole. So we need to get this into moles now. It's a little bit hard to see with the glare, I guess. Maybe I'll move that a little bit. It says Ag, silver. Okay. We have 63.5 grams of silver, and we need to get that into moles. Well, in 1 mole of silver, if you look at a periodic table, the molar mass of silver is 107.868 grams. Right? This conversion factor right here, again, is just the molar mass. And if you do that, you should get 0.589. So we did percent to mass, mass to mole, and we're just going to pause right there, okay? We're going to come back to silver in a little bit. Let's just go straight to nitrogen now, okay? I want to get keep these in moles. Okay. So, let's work with nitrogen now. We have 8.20% nitrogen, and that's going to just be 8.20 grams of nitrogen. Convert that to moles. In 1 mole of nitrogen, you have 14.007 grams. And again, you find this right on the periodic table. If you do that math, you should get 0.585 moles of nitrogen. You know, we'll just leave that. Never mind. All right. Last, let's go to our oxygen. 28.3% oxygen equals 28.3 grams oxygen. Convert that to moles. 1 mole of oxygen, the molar mass of oxygen is 15.999 grams, or just 16. And if you do that, you should get 1.77 mole oxygen. Okay, so we did percent to mass and mass to mole. But what's the next part in the jingle? we have to divide by the smallest. So what does that mean? It means we're going to look at our 3 moles here, and whichever is the smallest, we're literally going to divide all 3 of them by that number. So looks like it's nitrogen, 0.585. So I'm literally going to just divide now by 0.585 on all of these. Excuse my handwriting. And if you do that, I'll go to a new color here just to mix it up a bit. You don't get exactly 1 because, again, it's 0.589 divided by 0.585, so not the same number, but it basically equals 1. Whenever we do division at the very end here where it's divide by the smallest, we want to keep it to the closest whole number we can get. So 0.585 divided by 0.585 equals 1. And if you do 1.77 divided by 585, you get about 3. Right? What do these numbers mean? Well, these numbers just tell us exactly how many atoms of each element there are in our empirical formula. So this is 1 atom of silver, 1 atom of nitrogen, and 3 atoms of oxygen. So our empirical formula, using what we know here, will be AgNO3. And if you remember your nomenclature rules, the name for this is silver nitrate. Okay, let's try another problem here. A compound containing 5.93% of hydrogen and 94.1% of oxygen has a molar mass of 34.01 grams per mole. What is its empirical formula, and what is its molecular formula? Alright, so it's pretty similar to the last problem I just did. Only difference is now I'm also asking you, what is this compound's molecular formula? If you don't know, again, just as a reminder, molecular formula is the exact number of atoms of each element in a compound, not the simplest whole ratio. So, let's just find the empirical formula first. Okay, we can do that given our 2 percentages here. So, what are our givens? We know we have 5.93% hydrogen. Remember, percent to mass, so 5.93 grams of hydrogen. And we need to convert that to moles. Well, how many grams of hydrogen are in 1 mole? You can find that right on the periodic table. 1.008 grams of hydrogen. And if you plug that into a calculator, you should get 5.88 moles of hydrogen. All right, let's go on to oxygen. Oxygen, we have 94.1%. This compound is comprised of, this compound's composition is 94.1% oxygen. If we convert that straight to grams, we can go to moles. And periodic table will tell us the molar mass of oxygen is 15.999 grams. If you do the math on your calculator, you should also actually get 5.88 moles of oxygen. So here's the nice thing for us when determining the empirical formula. We have 2 numbers that are exactly the same here, same number of moles of each element. Remember, divide by the smallest, so 5.88 moles. Right? I'm getting this 5.88 from either or, really, hydrogen or oxygen. Remember, we're just dividing by the smallest number of moles. And in this case, they're both 5.88. So if you do that math, I don't even need a calculator to do that. I know that I have 1 hydrogen and 1 oxygen. And together, we get our empirical formula, which is just HO. Lovely. But we're not done, because now I also want to know what our molecular formula is. That's where this 34.01 grams per mole is going to come into play. Now, molecular formula is the exact number of atoms in a compound of each element. The exact number of atoms of each element in a compound. Cannot phrase that correctly, my bad. Now, to determine the molecular formula given the molar mass of the compound, all you have to do is take the given molar mass divided by the empirical formula molar mass. Oops, that's supposed to be M. Empirical formula molar mass. And that'll give you a ratio, and we're going to use that ratio and multiply it by the empirical formula. So our given is 34.01 grams per mole. And the molar mass of HO is 17.007 grams per mole. If you do that math on your calculator, you should get 2. And what are we going to do with that number 2? Well, we're literally just going to apply this 2 to each atom in our empirical formula. So our molecular formula is just going to be H2O2. Lovely. And that's how you do an empirical formula problem in combination with molecular formulas.